Okay, so here's a something else I got in the mail. Actually, I ordered this a while back. My razor blade. Careful not to cut myself. Okay, so I think these are the frequency counter kits that I ordered. Ordered some frequency generator kits too, but I thought maybe they'd be together. I don't think I ever got them. That should be interesting. And as I learned before, this says frequency tester on it. One is none. I ordered one of those Wish Tesla coil kits, and I tried to assemble it, and the thing did not work. And the directions were so terrible, I could not get it to work. And so I guess if you have two of them, and you mess up on the first one, or they leave out a part or something like that, then maybe you have a chance of getting the second one to work. Maybe they'll include all the parts in the second one. Okay, so let's take a look at this and see how this goes. Okay. Okay, so here's our frequency counter here, and I ordered two of them as I've been suggesting, since I made the mistake of ordering one time before, and I think it was missing a part or terrible directions, or I goofed it up, or ordering a second one will always help you out. Oh, look at this. Okay. So it looks like, let's see how the directions are. Okay, oh, they're in English. The welding installation considerations following the steps. Well, I would call it soldering. But it is in English. Look at that. We have a circuit diagram and some type of directions and parts list. Okay. They tell you what the resistors are supposed to be and the capacitors. Okay. Here's our active components, it looks like. One chip with a bunch of pins. 1, 2, 3, 4, 5, 6. Is that 9 on one side? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 18 pin dip and a 5, 8 digit or 7 digit 7 segment display, and a I like those little holders so you can take out the chip while you're soldering and replace it if you burn it out or something. And let's take a look in here. Looks like we got a bunch of resistors and screws and stuff. And it looks like here's a USB adapter for the power. So it must run off of 12 volts, or whatever USB is. 5 or 12, one of those two. And looks like it's some kind of plexiglass box. It's going to be pretty nice. Looks like it fits together with tabs. Okay. And here is our circuit. And I think we might start populating this up. Maybe I assume you want to take the, usually they have some kind of tape on these plexiglass parts because it makes it stronger while they're machining it. I don't know if maybe they laser cut this stuff. Well, it seems to be kind of difficult to get a hold of this paper thing. Okay, there we go. Okay. We'll take off this paper because we start assembling our little frequency counter thing. This is pretty exciting. I think I didn't pay too much for these also. I think it was around $10 or less. Okay. Okay, there's one side. I should emphasize, I know I make lots of different videos, and you never know what kind of Easter eggs I might be hiding in them. There's a reason why, for instance, if I got a frequency counter kit, it's always a reason why I got this. It's related to something else I'm working on, which might be more interesting too. Oh, look at that. I'm getting a frequency counter. It's not just for the purpose of doing frequency counting. It's because I have a bigger plan in mind. It's clear. Very nice, huh? Let me get all the rest of the parts undone and we'll try to assemble the box and see what that looks like. Okay, I think I got all the plastic off these parts. It's really hard to see them on the camera. This is definitely the base, and just kind of use this to guess how to assemble this crazy thing. I'm going to guess that the button's going to go under the hole here, and the power supply output's probably going to go where this is notched out, and maybe this is going to go, I don't know, there's one that's got a notch out of it, so I may have to assemble the whole circuit. I'm just going to test fit this together to see kind of what it looks like. Okay. Oh, there's a notch out of that one too. I wonder what that's for. Anyway, probably have to put the circuit together and find out. Okay. Looks like it does pretty much fit together though. Oh. I assume there's going to be screws in the four corners to hold all these parts together. Okay. And there we go, a nice clear plastic box. Okay, let's try to populate up the circuit. Oh. Anyway. Oh, I see. Oh, this one's missing a tab, so that's telling me where that slot's supposed to go. I guess it's supposed to go there, so it won't fit in where there's no tab there. So maybe that's for the power wires coming in. Okay, there. So there's a little slot here, and a slot here for, maybe one's for the input of the power, and one's for the input of the frequency. I'll have to put the circuit together and figure this one out. Okay. A pretty nice kit for what I paid for it. Assuming it works. If it doesn't work, then it's not going to be worth it. Definitely. Okay, usually I like to start with the resistors. And so we have lots of resistors here. And, oh, come on. Okay, I guess that's all of the resistors. Let me find my voltmeter, and I will check these out to see what they are. And I like to start with the ones that are all the same as much as possible, because then I can populate those up quickly. Okay, so let's take a look here. Okay, so it looks like these are 1K resistors. That's a very popular, let's see if we can get that on the camera. Basically 1K. And of course you don't want to touch the two resistors, and you don't want to touch your fingers to the leads because you actually have resistance through your body, so that would mess up the resistance measurement. So if we look at the directions, it looks like there's two slots for 1K, R4 and R6 through 13. You can see that. We'll see if we can populate those up, and we'll go on to the next step. Let's see, let's take a look here. I may have to put it under the magnifying glass up there. Okay, so it looks like R4 is under this thing that's probably a transistor. Excuse me. And R6 through 13 is up here in the corner. So all these are 1K, so let's go ahead and populate those up. Again, we measured this to be all 1K, so let's take a resistor out of there and start putting these into where they want to go. Are supposed to go. So there's, R4 is right there, and we'll get another one. R6 is up in this upper corner up here, right here. Okay. And the rest of them are right up here in this corner. So let's go ahead and populate that. Okay, so I think I have all the 1K resistors populated up. The one down here and the, 5, 8, or whatever up there. Okay, so let's move on to the next one. Okay, here's the next set of resistors, and there's 3 of them. And these are about 10K. Okay. And if we look on our handy-dandy little chart here, looks like resistors 2, 3, and 5 are 10K. So there's 3 10K resistors. Let's try to find where those go. We'll plug them in. Okay, so looks like resistor 2 is over here, 3 and 5. So let's plug those guys in. Okay. Okay, so I just put in 2, 3, and 5, and there should be one left, and I'll measure it. The resistor 1 is supposed to be 100K. Let's see right there, 100K. Okay, and appears we have one resistor left, and I'll measure that to make sure that's 100K, and we'll put that into our circuit here. Okay, so there's our 1K resistor right there. Okay, so maybe I'll start putting the diodes in next, and always remember, diodes have a polarity. Resistors don't make a difference which way to go, but the diodes will have a stripe on them, and they let the current go in one direction. If you stick them in backwards, the current's going to go in the wrong direction. This could burn something out, could cause a lot of problems. Probably the circuit won't work. That's the reason why they put diodes in there. And they don't want them backwards, so mind the, let's take a look at the diodes. So, see there's a little stripe on the pattern here on the top, and there's a little black stripe on the diode here on the top. So that stripe's got to go in the same direction as that stripe on the screen printed diode thing on the circuit board. Okay. Okay, so I got the 4 diodes in up here, and got the polarity right. The black lines are at the top, and the 5th diode is over here next to that resistor, and the black line is pointing to the left. So we want to make sure we got that one in the right polarity. And again, I like to bend the leads outward on all these so that the components don't fall out while I'm working with it, and then I can solder them all up at once and do this very quick and efficient. Okay. Should be interesting. Okay, let's start with the capacitors next. So I'm going to start with the 104. So it says C1 and C7 are both 0.1 microfarads, and the label is 104. And if we look here, we have two capacitors that are labeled 104. And it looks like C1 and C7 are on either side of this U1, which is going to be our regulator. I looked ahead in the directions. So let's get these guys on here. And again, I'm looking through my magnifying glass so I can see these silly little parts. Okay. So these are probably to buffer out the regulator. So there's C1 and C7 capacitors. Okay. And let's see where we go next. We'll populate the board, I guess, with capacitors next. We'll do all the 2-lead ones first, then we'll move on to the 3-lead. Okay. Okay, I'm going to do, skip around a little bit. I'm going to do the 22P ones. So if we look at C2, C3, C4, and C5, for some reason they're on different lines. These are all labeled 22P. These capacitors don't have the P on them. I assume that's picofarads. They just got 22 on them. I don't know if you can see that through the magnifying glass or not. I can kind of see it because I'm close to it, but they just have 22 written on them. And let's populate them into the circuit as well. Okay. Okay, so it looks like C2 is right there. Where was C3? C3 is right next to it. C4 is up there. And I saw C5 a second ago. I'm not seeing it now. I thought that was C5, but that's actually C6 there. Okay, well, let me get those in. 2, 3, 4, and 5. Oh, C5's over here on the other side of the crystal oscillator. Okay. We'll start populating those up. Put the 22Ps in here. Okay. These, if you don't have one of these magnifying glasses, they're really helpful, especially when you start getting older. Okay, so C2, 3, 4, and 5 are all populated up. Okay, let's see what's next. Okay, looks like C6 is the last one, and it's labeled as 102. And this one definitely has a 102 written on it. And again, number 6 is right over here, so we'll put that guy in. Okay. There we go, and I think that's it for all the capacitors. Looking pretty good, huh? Okay, so now next part's going to be annoying because there's three leaded components. One's a regulator, labeled 7550, and the other two are NPN transistors, labeled S8050. And so that means we're going to have to read tiny little writing on these guys. Okay, I can see this one's labeled S8050 and that one's labeled S8050, and I don't think I can read the writing at all on that one. So this one here has got to be our regulator. Okay, it's like solving a puzzle. Good thing there's not a lot more of these parts that are unlabeled, because it would be impossible to make this stupid thing work then. Okay, so that's U1, and so if we look at our circuit, U1 is right here, and I assume the flat side goes to the flat side of the transistor. See how there's a flat side on it? Okay, and of course the leads are always spread way apart on the circuit board, so I have to get all the leads into the right holes there. Okay, so there's U1, our regulator, and while we're at it, we know that U2 and U3 got to go in the other slots, right? And it looks like U3 is up here, and of course you want to get the transistor in the right direction, because the pins, if you swap it around, it's going to ruin something. Okay. So U3 goes up there. I just kind of bend it until they all fit into the right hole. And it looks like U2 is down here. Okay. So let's get that one in there too. And remember, flat side to the flat side. And I try to get it in the first hole, then bend it so the second lead goes in the second hole. And then bend the transistor some more so the last lead goes in the last hole. So there. 3 transistor, regulator, whatever. Three leaded components all seated in with proper polarity. Okay. Okay, so the next thing is this crazy looking switch, and I wasn't sure which way to go it goes, or if it doesn't make a difference because it's got 4 pins. It looks like the pins are always conducting from the top to the bottom, and when you push the button down, it momentarily makes contact between this side and that side. So it seems to be symmetric. So I'm assuming there's no difference between the up and down on this guy. So we'll stick that guy in the hole. And let's see, what else? There's a couple jumpers. Getting close to being done. Oh, wait. That's interesting. Some of these are uppies and some are downies. So I'm going to have to figure out which is which. Oh, here's a crystal. There's for keeping the time, and the crystal goes right here. I want to put that in kind of last because it's got short leads, so it might come out. Come on. I'm going to need some tweezers or something to stick it in. Okay, there we go. Says what, 20 megahertz? 20M 16H now, so whatever that means. There's the crystal. And here's our power plug. And getting down to the last few components. Like I said, I wait to stick the IC chip in until after I get done soldering it, just so that I don't put it in danger from ESD, although I don't think I've ever damaged anything from ESD, normal ESD. And or heat from the soldering iron, which I don't think I've ever damaged, except for when I was using an inappropriate soldering iron one time, using like a pipe soldering iron for soldering, plumbing. That would get hot enough to damage circuits. Okay, so see there's a little tab here, and there's a little tab on the side of our IC plug, IC socket. Okay, so it goes in there like so, and here's our 7-segment display. I'm going to assume, well, I don't have to assume, see there's the dots go at the bottom. So we'll line that guy up. Ooh. Come on. Those pins there's a lot of pins on it. You want to make sure that they go in the hole right, or else you will bend the pins, probably, and that would not be good. In fact, I'm having troubles getting it in the hole right now. Oh, come on, come on, come on. Looks like one of the pins is bent down a little bit more than the rest, so maybe I'll have to take it out and rebend that one a little bit. Make sure they're all about on the right level. Okay. Oh, come on. Okay. I guess just be patient because you don't want to... Okay, there. We got the 7-segment display on, and I guess this is the output, and I believe that the box has some kind of opening, so I'm going to assume that the output's going to go toward the outside. See, it's got little screw terminals you can screw down, hook wires into. One's in and one's ground, so that's got to be the input of the signal generator, or signal frequency counter. And let me look at the directions and see if I can figure out which jumper goes where, because we're down to an ambiguity now. I'm not sure which one. There's an innie and an outie, like I said. One of those is a female and the other one is a male, and I don't want to have to unsolder it when I find out it's the wrong thing. So let me look at the directions and see if I can figure this out. Okay, so it looks like J1P is a 3-pin Resistors interface hole seat, and the other one says it's a jumper cap. So I'm going to assume that we do have a little jumper that's going to go across the pins like so, and so you're probably going to change the mode of it by jumpering it differently. And so I'm assuming that the J1 is the one with the pins up, and the other one that says holes on it is where the holes are going to go. Okay. Okay, so here we go. I guess the holes, this is JP, so I guess the holes are going to go there, and the jumper pins are going to go right next to the blue guy. Oh, come on. Maybe I'll have to put this one in first. It's not easy to get that one in place with that blue thing in the way. Okay. There. Okay, we'll put the blue thing back on. I think our board is all populated up and ready to be soldered. Okay. Very interesting. Okay, so here we have our circuit here, and I'm just going to, I got a soldering iron all heated up. I like to use the fine tip on this type of stuff. Oh, of course, I'll have to solder these in later, I guess. So as I said before, I bent all the leads outward so the components don't fall back out due to gravity. And I'm going to solder these up. I'm not going to probably do the whole thing on film because that would be really boring to watch. But let's just start soldering these components up. Again, I heat up both the pad and the wire, and bring the solder in and touch it until it flows. Okay. Now we'll just go through and solder all these parts down. Try to do this as quickly as possible, because there's lots to do, lots of other fun stuff to do. So we got to get our circuit working. Okay, and I'll just go through and just keep on soldering these parts on, like so. Make sure not to make solder bridges to other pads or anything, because that would not be good. Okay, again, hold the soldering iron at the pad and the wire, heat them both up so the solder flows over both of them. And we should be good to go. Lots of wires to solder here. Okay. Okay, I've soldered all the long leads, and I think I'm going to clip them before I solder the short ones. And here is something called a pair of dikes, and these are great for clipping these leads off. Probably be better if I had a finer set of dikes, but this is what I got. So sometimes when you wiggle them, smaller ones would probably cut it a little bit better. Cut them, and I guess if they don't come off, wiggle them a little bit. We'll get rid of all these wires on here. Trim them all down. Okay. So let me go ahead and work on that, and I think we're getting close to being done. Okay, it looks like I was able to cut all those leads off. You want to make sure, I couldn't get these as short as I wanted because I was using a bigger pair of dikes, but you want to make sure that none of these are touching together, because that would definitely make the circuit not work right. Ideally you want to cut them right at the base so that they can't touch together, but my dikes were a little bit bigger than what I like. So just go through, make sure there's no solder bridges or wires touching together or something. Make sure the circuit looks good before you continue on. Okay. And I think I'll solder up the rest of these short. Okay, so I guess let's finish up this circuit. Here we have I got this thing all soldered up, and I haven't put the IC in yet. Here's the IC, and remember there's one side where there's a little notch on the IC. Their orientation does make a difference, and that goes, there's a notch in the plug over here, and usually I have to be careful and squeeze the leads down just a little bit, because they're usually a little bit too wide to fit into the socket. And you want to be careful when you're sticking them in, make sure all the, yeah, see, it's still a little bit too wide. Just squeeze them down a little bit. Okay. Make sure every single lead fits into every single hole there, because if you don't, you're going to bend them when you press it down. And if you bend a lead and try to bend it back, it might break off. So you don't want to do that. You want to be very careful. Okay. I think I got everything lined up. And there we go. Looks like all the leads went in place. Okay. And let's look at it. Okay. So we also have this little jumper thing. It's got an extra tab so you can grab it up high. And I believe the jumper thing goes on to these wires here, and the directions say something about switching it between the two, and one's for testing, I believe, and one's for running the circuit to measure frequencies. I'll have to reread the directions because they're not super great. Okay. And the last thing is this snap-on button, and I believe that goes on to this guy here. Somehow. I think there is a difference on, well, let's see. Okay, there. Okay, I guess he snapped on. And let me move him a little bit away from this transistor. And I guess let's build the case and make sure that everything fits in there. Here's the plastic part on the bottom. I don't know if you can see that. This one looks like it has no orientation. Looks like there's screw holes to hold the circuit in the middle of that. And then there's screw holes to hold the box together. Okay. Okay, I'm going to assume that the shorter screws, we have shorter screws here, are to hold the circuit together, because that's a smaller distance. And seeing as this thing seems to be perfectly symmetric, I'm just going to go ahead and mount the circuit. And then we'll try to figure out how the rest of it goes. There's a little nut on the back. There, see? Okay, so we got 4 of these guys, one at each corner. Like so. Do we have 4? Hopefully we have 4. Okay. Oh yeah, and before I stick this together, let's get these screws in place first, I guess. Okay, and there's the 4th one right there. One at each corner. I had to cut a couple of wires that I had around here, because it looks like you have to supply your own wires for the input here. And here's a terminal block. Oh, come on. So I'll open these up with a small screwdriver here. And I think I will use the black wire for ground. Just fit it into there, and then we'll screw it down. Okay. Like so. And a red wire for the input, because you always need 2 wires to make a circuit. Right. And there. They seem to be screwed into place. So let's get the rest of the parts of this box out. So there's the top, and it looks like it fits on like so. Okay. But we need to put the sides on first. And the sides are all the same except for these two, with a couple notches taken out of them. And so, assume this side here, with that notch right there, is going to allow you to take the signals out for measuring it. So I put that notch right here in front of the blue thing. And then we have this one here with a notch. It's so hard to see that notch on the camera. You have a power input here, so we gotta be able to fit that there. I believe it's gotta go with the notch facing up here. That looks like it fits almost perfectly in there. Okay, so you can still get to the power input. Maybe it's not quite perfect. It's bending out a little bit, so we may have some issues. If I don't get the... come on. We'll see if we can get the box top on, because it looks like it's bending out a little bit. And the other ones seem to be perfectly symmetric, so we'll get those on. And I might have to fiddle with that, because it looks like it's having a little bit of interference with the plug thing here. Come on. Let me fiddle with that, and then well, what the heck. Let's see if we can force it on. Okay, there. Oh, there we go. Okay, I just fiddled with it a little bit, and now it's popped on. It's flush with the plug now. Okay. Get these things back on. We'll see how this box fits together. Okay. Looks like that plug thing is going to extend up a little bit too high, maybe. Come on. Okay. Chinese puzzle here. Alright. Literally. Okay. So I guess it does extend up too high, but they have a notch cut out of this piece here to compensate for that. So it looks like... okay. Looks like all the parts are probably going to fit together if you fiddle with them some. The top one's not lining up. Okay, there we go. Looks like all... oh, something's not fitting right. For some reason this... oh, I'm interfering with the transistors here. The transistors are hitting at the top here. But I think we can just bend the wires a little bit. Pull this back off. Bend these over a little bit. Like so. Okay. And I think the box is pretty much together there. I think we got all the tabs in. It's sitting down flush. And so we have these long screws that can go through the corners here. And nuts on the back side to hold this thing together. Like so. Okay. Come on. This screw seems to be having some issue going in. I can twist it to force it in. Oh yeah, this one's not going in easy. What the heck? Oh no, I think there's going to be interference here with the plastic thing. This plastic thing's not quite fitting right. Okay, that's not good. Let's get the rest of these together, I guess. Maybe I'll have to leave that screw off. Or file a plastic thing down or something. This is getting some interference with the plastic thing in that corner. Looks like it was designed a little bit too close there. Well, anyway, just let me fiddle with that. Maybe I can figure this out. Because the one screw's not fitting in. You can probably hold the box together with 3 screws, though. Oh, it looks like I have a bunch of extra nuts. Maybe these are supposed to be like jam nuts at the top. Although I don't have any idea how you could fit an extra nut in there. The interference is so close that this screw won't even go in. Okay. Okay, so we have this USB power cable that came with the computer. Let me just undo this, and I guess we can plug that into our computer over here, get it power, and I don't know. Remember, you always want to make sure that your circuit's perfect before you plug this in. I checked all the bottom to make sure that everything looks like it's got a good solder joint and not shorting out or something, because once you plug it in, if something's not right, it will possibly destroy something. Okay, so our circuit says 0. So we have a signal generator up here, and I have it hooked to these leads, and so let's hook our signal generator up here, and look at that, 9.94. It's about the same as this up here. Maybe try twiddling the frequency, maybe. Okay. Look at that. Seems to be tracking with the frequency. 1.5, 800. This is on the megahertz scale. Let me put it on the 1 meg scale. So that's 94. And okay, look at that. So it seems to be tracking with the frequency pretty well. Pretty good response. As good as the meter. Okay. Let me change the setting here again. Gone to 100K scale. So that's probably like 9 kilohertz. And okay. There's a decimal point there. And we'll go down to the 10K scale. 900 hertz. It seems to be tracking down there. Okay. Go down to the 1K scale. Okay, 88 hertz. Up to 1K. Let's see. What scale we got? Going to the 100 hertz scale. 9 hertz. Seems to be in agreement so far. 30, 50. It's pretty good. 10 hertz. Let's see what this goes down to. Okay, that's about at the limit what we can measure with this device. Okay, pretty cool. I'm not sure what this button is. I'm almost afraid to hit it. It's a reset button. I'll bring this back up to 10 megahertz. 8. Okay. There we go. Okay, so I'm going to look at the instructions for the jumper of this guy, because what is that expression? It's not broken, don't fix it. Looks like it seems to be working. So let me see what's going on with the instructions, those horrible instructions, and then I'll decide whether I'm brave enough to push the button or change the jumper, because it seems like it's working right now. Okay. Anyway, okay, I got the courage up to push this button. So when you push the button, it looks like it goes into different modes. It says quit, no pulse J maybe, add, subtract, 0, table, and then I found if you just hold this down for a second, you can get back out of this mode. So I'm not sure what that mode is. It looks like you can do some fancier things with the probably have to look up the spec sheet on this, because it looks like this chip might have some fancy options or something. It's basically a whole frequency counter on a chip, and someone just made a board for that. And I guess this jumper is to check the frequency of the crystal, so maybe I will unplug the power supply and just check the frequency of the crystal. And it's like a calibration thing or something. Okay, so let's try that, I guess. Unplug the power supply, and I'll change the jumper to the top setting. Okay, I'll plug that back in. And I don't know, it's just reading 0. So I have no idea. This thing doesn't work either. Well, either the circuit's messed up or we don't care about that function. Hopefully the thing will still work once I plug it back in down there. Okay, good enough. That's all I wanted it for anyway. So cheap frequency counter, and okay, comes in a nice little box. 3 of the 4 screws fit. I could maybe run a drill bit or a file down there, or maybe take it apart and file or sand down the end of that corner to fix that. But anyway, there we go. I think it's pretty good. Okay. Anyway, this is Dr. Janes, and thanks for watching.